Okay, 10.2, find arc measures. Our objective here is I can find, or I can use, arc measures to find angle measures. I need to slow down with that. I can use angle measures to find arc measures. So our essential question is, how do I use angle to find arc measures? Now, just a reminder that I zoom through these videos, so please to pause the video and take notes and think about what I said, read yourself, and only listen to the video with understanding. Please don't just, the goal is not just to copy down. So in other words, as you see all my colors and so forth, don't just ignore what I'm saying and copy down the colors. You're welcome to do that, or maybe listen to the video a second time and make sure that you are listening with understanding. It's what's going on inside your brain that is important, not just what you are on the page. So, central angle. What is a central angle? Well, the central angle of a circle is an angle whose vertex, remember when we did the regular pentagons or regular polygons, we had a central angle. Same idea here. So when the vertex center, that is going to be a central angle. And so this angle ACB is a central angle. Remember always designation of a angle, and there are 3 letters. It is this center letter that is your vertex. And if the measure of 180 degrees, then the points on circle C that lie in the interior of angle ACB form a minor. What they're saying is, here's angle ACB, and you can see that this angle is less than 180 degrees. And so as this central angle comes out, it enters your circle, and the arc created by all the points within this angle are going to be a minor arc. In fact, it's going from point A to point B, and it's a minor arc because the central angle that created that arc is less than 180 degrees. And they're saying that the other remaining points, all these are going to be a major arc. So you don't really, I guess you could measure the angle, this exterior, I don't know if it's really called an exterior angle, but it's more than an obtuse angle. It's flopped all the way on the back side here, and you can see this is greater than 180 degrees, and so the arc. So in the blue is a major arc. And then a semicircle is a arc created by a central angle that is 180 degrees. So if you had a central angle DCA, that angle here would be 180 degrees. Create, on the left side at least, over here, it would create a semicircle, and you know also it would create a semicircle also. So notice, let me emphasize, it says it here in the book, naming arcs. Notice that for major arcs, we need 3 points with it. With a minor arc, we only need the 2 endpoints. That's fine, just from A to B. But when we have a major arc, include a 3rd point, because if you just had the 2 endpoints on this major arc, then it would just be, and you always take the shortest route between those 2 endpoints. So if you were just to say AB, it would be the minor arc. To force us to go the long way around the circle, we have to have a 3rd point on this on this major arc, whether it's point D or point E was over here or point F over here. It does not matter where it is, as long as it's on the major arc and it forces us to go around this circle and not just do the minor arc. So major arcs will always have 3 points to them. The measure of a minor arc is the measure of its central angle. So here's the central angle that creates this minor arc, that's 50 degrees. And then the measure of that arc will also be 50 degrees. You know the measure of the entire circle all the way around is 360 degrees. So therefore we can figure out the measure of this major arc, arc A in this particular case, is going to be 360, the entire circle, and then take away the minor arc of AB. So 360 minus 50, 310 degrees. So in this particular case, this major arc is 310 degrees. The remainder of what's left over after you take 50 degrees out of the 360 degrees. Let's look at some examples here in our book. Example number 1, and we want to find the measure of this arc. Now, let me make sure to emphasize the notation. So when it has the italics lowercase m, just like with so this is the measure of angle ACB. So also here, we say this as the measure of arc AB. So this arc on top tells us that the lowercase italics m tells us it's referring not to the distance, the length of arc AB, but the measure of the central angle. And the measure of the central angle is a measure of the arc. So back to here. We want to know the measure of arc RS. RS measure of this arc. Well, you go to the central angle that creates this arc, and it is 110 degrees. So therefore, the measure of the arc is also 110 degrees. And now they're asking for the measure of arc RTS. There's 3 letters there. We expect that that's going to be a major arc. And here's R. Now I could go toward T in this direction, but it would go through S. So I couldn't do R and E and then back to S. So therefore it's got to be going counterclockwise, R and T and S. So this is the major arc that's being referred to. Well, I know that this minor arc is 110 degrees, and so the major arc for RTS needs to be, there's 360 degrees minus 110, so that's going to give me 250 degrees. And then they also want us to find measure of arc RST. Well, that's easy. RST, assuming that RT is a diagonal. What am I saying? Radius, diameter. There's the word I'm looking for. So assuming that RT is a I missed it again. Radius, diameter. Why am I having such difficulty with that word? Assuming that segment RT, then what's on this side of the diameter is going to be 360 degrees, and so RST is going to be, and I even said 360, didn't I? Is 180 degrees. Yeah, this is what sleep deprivation does to you. It makes your brain not, or maybe that's just, and normally doesn't work anyway. So next page, adjacent arcs. You know the word adjacent means beside, alongside of one another. And opposite arcs. We don't really use the word opposites with regard to arcs, but adjacent means side by side. In other words, they have this thing, adjacent arcs. And postulate 23 here says, I have it in your notes, the measure of an arc formed arcs is the sum of the measures of the 2 arcs. So the measure of the arc that's formed by 2 adjacent arcs is the sum of these two adjacent arcs. Well, they call it a postulate. Remember, postulate, a synonym of the word postulate is axiom, and both and axiom mean, or the definition of those words is that they are self-evident truths. So this is a self-evident truth. In order to get the measure of the blue arc, I would simply add the measure of the pink arc plus the measure of the green. Right? Pink plus green equals blue. That's simple enough. Example number 2 in your book. They have a survey of teenagers, and notice that what's here is not the percentage. It's not saying this is 108% of the teens surveyed, nor is it saying 108 teenagers, but it's saying the central angle of this this angle, the blue angle here, is 108 degrees. And so therefore, the measure of this arc is also going to be degrees. So when they ask for the measure of arc AC, A going to C, remember, you go the shortest path, and they don't give us 3 letters, so we assume it's going to be a minor arc. Go counterclockwise over here, but instead from A to C go the shortest distance, and the measure of that arc is going to be simply 29 plus 108, and that's 137. The measure of arc ACD, so I'm pushed to go toward C, and also D, is going to be C was, and then adding CD. So AC was 137, and CD is 83. So that adds up to 220, or if I wanted to just say, that would still give me 220 degrees. The measure of ADC, so now I'm pushed around in this direction, and so I would just simply add the 79 plus the 61 plus the 83. I could do that and get my measure, or remember I found the measure of arc AC, and so that's the minor arc. To find the major arc, that I would simply take 360 and then subtract the minor arc from it. So 360 minus 137 will give me 223. So and notice here it says AD. You could also designate that as AEC. But all you need is just 3 letters. You don't need to include all 4 of the points here. You just need 3 points for a major arc. And then the measure of arc EBD, E and B and D. So we're swinging over in this direction, so all the way around here. And you'll see that what's remaining is this minor degrees. So rather than go through and add up all of these angles going around the major arc, all that I need to do is just take 360 and subtract the 61 degrees, the minor arc of 61, and what's left over is the 299 degrees for your major arc around this circle. Okay, guided practice 1 through 6. You have this here in your notes, so go ahead and pause the video now and work through those. Again, if you need to, go back and look at the book first of all to find process, and if you want to replay that portion of the video to help you, you're welcome to do that, of course. Now, congruent circles and congruent arcs. All they're saying here is that 2 circles, to be congruent, they have to have the same radius. And yes, it is true they could have the same diameter or same. That would also prove that they're congruent, but the easiest way to do it typically is to see that they have the same radius, and that's all we need to know. Circles have the same radius, then those 2 circles are congruent. And in order for 2 arcs to be congruent arcs, then those arcs have to have not, but also the arcs need to be of this either the same circle or and so let me make that clear and why that is the case. So let's look at here example B, and notice that these two arcs, the inner arc and the outer arc, do have the same measure. They're both 90 degrees. See, this inner circle is a smaller radius, and therefore the arc, though it has the same measure of 90 degrees, it's a smaller distance than the length of this larger circle that has a larger radius. So in other words, so that's why, in order for arcs to be congruent, they have to have not only the same measure, but also either be of the same triangle, or I said triangle, the same circle. There are two arcs that have the same measure, and they are also of the same circle, or they have the same measure of the arc, and also the circles they are in are congruent to each other. So how do I know that these two circles are congruent to each other? Well, they have the radii for the circles are congruent to each other. So therefore, these congruent to each other. Okay, so now it's time for you to do guided practice 7 and 8, which you have in the bottom of your